Where was this?
我就说你去哪儿了？
What is conflict court? When was this?
你去哪儿？
When was this? I remember this. Oh yeah, I
我就
remember
说
this. Friday,
你去哪
right?
儿？
Me! Me getting the chocolate. She's trying to mouth. They reunite.
啊，不是说找到妈妈。 Oh, it's live.
Really?
Yep. It sure is. Live arena.
This isn't the hardest in the world. No.
It
There's some
is.
questions that have been unsolved.
This is for year 10s. There are no questions for year 10s which are unsolved.
Oh, for year 10, this is probably the hardest. This isn't the hardest in the world. It's probably something harder.
What would you know?
Like, what is X? No one knows what X is. Not even Albert Einstein himself.
You say some stupid stuff. Just be quiet, okay?
But what is X? Can I have one? After your move legs, can I have one? Please? Please. Okay. Michelle, when it's in the cube like this, it's good to chew on. But when it's small, it doesn't really need to be chewed on. It just doesn't feel very good. No.
Press the key.
What's that? See soccer jerseys.
Sean.
Hello?
Hello? Hi, Sheldon. 哦，好的。
Young Sheldon? Young Sheldon? Like the TV show?
Sheldon. 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 是6点接吗？差不多大概6点接。对。好，接着见啊。好，一会儿见，拜拜。Let's do this.
You think when the rumbling will affect the line?
Oh, 哎，你直播啊，拜拜。
Oh, so the question is like the 100 bishops on 100 by 100 chessboard, and what is the least is that will guarantee only one bishop on the chessboard left?
Yeah. Hey, welcome.
Do you see that ring?
It's crazy rain today.
I know, and the lights were flickering themselves. Bro, when I was in the elevator, like, I heard a big thunderstorm and glass shattering. Like, it actually, where did the glass shatter? I don't know, it just sounded like it. I was in the, Michael. Somewhere, like, I saw this fire while I was about to go to sleep. Michael! And then I saw this spot going down onto the land. Oh, that Michael, which elevator were you in? No, but we were about to enter the elevator.
Okay.
Elevator was still open and
啊，进去了。
well, that's a lot of zappers.
啊，好好，好，一会儿见，说拜拜。
do you want one? If I need help, I don't know how to. Oh, zappers can you wrapping. Yeah, I know. Zapper can you wrapping. The other one's like purple wrapping and now this one's see-through. I also have this. I'm gonna get zappers every single time I go to 7-Eleven. Why is it so hard to eat? Whoa. What the? You really tripped yourself just like me? What if I have apple and grape together? Oh, wait, can we just use a blender? Yeah, we can. Look at the very open. Did you know I was... You know, I was just peacefully walking with my friend with a small umbrella. My friend.
I think your mom's worried
And
about
then-
her. Mom's gonna call Duca, right? Hmm. I don't know. Hopefully they found each other.
Wait, is she out by herself now? No,
She went into the building. I thought that was her home.
Yeah, it's her cousin's house.
Alright, guys, focus on solving this problem. See the problem? You guys need a hard copy. The very last one. Gabriel, if you're interested in the other ones, we have the other ones on video because you missed the class, yeah? What? I already told you something, you didn't listen to me at all. Hello, Lucas.
Hello.
We haven't really started yet. We're just looking at this problem.
100 times
I already
110,000.
have your YouTube.
Oh, okay, good. Yeah, pretty excited for New Year's camp, huh? Sydney Academy Sport.
I'm excited. I wish I could go to Broken Bay.
Broken Bay is already over. Hey,
I know.
focus on this. Don't get distracted. Don't distract other people. Yeah, so I guess, have you had a look at the problem? Any thoughts?
Not really.
Oh, you want some paper too, Gabriel? I'll give you a hint in 5 minutes, okay? And I want you to think about the problem. Oh, that's this.
Wait, only one bishop remains on the board, does that mean does there have to be like 99 of one colored bishop and one bishop of another color?
No, there could be any number of different colors, white and black, that add up to 100.
What if they're all black or all black?
But they can't be all black. They can't be all white.
So is that like a normal chessboard, like crisscross? Well, not really, because it's 100 by 100 times 100 is 10,000. I think the world's biggest chessboard is that much. Papa, for practice, can I just turn the question smaller? Well, solve the question. Can I just make the question smaller bit and change 100 to a different number?
Yeah, I already said that. I'll say it again when Honest gets here. Hi. Honest, come in. Here, this problem here. I'll give you 5 minutes to look at it and I'll give you an introduction to it, okay?
Okay.
You can use this as paper. Different sheets. Use this one.
Wait, 10 minutes. So aren't there the equal amount of white and black?
No. There just has to be
Okay.
not all the same color.
Crisscross.
Alright, 2 more minutes, guys.
2 minutes?
That means if it starts with it will guarantee. Oh, so if it starts with only 1 white and 99 black, that means the white has to be the winning one.
The white has to go and kill all the black ones, yeah.
But if the black ones kill the white?
Well, if there's 2 black ones and it kills the white, then you can't do anything else. You lost.
Unless there's 1 black one that kills the white one,
But then, if it's 1-on-1, the white could just kill it as well.
Can you control how the bishops move?
Wait, does it have to be like different colors?
No, just for the fun of it. So if there's only 1 white and all of the rest are black, that means it will take 101 minutes. No. Yeah, 101 minutes. Only if it's in the corner though. Wait, or like near the corner. At the end, since in a chessboard the bishops can't cross colors, so
Yeah.
at the end there's going to be 2 bishops, except they can't cross each other.
They start all on the white squares, okay? So they're already only half the board is dead, is their playing ground.
So you need multiple pieces because then, if you have 1 white bishop, it could be like that 1 white bishop could be taken by another one. I'm just trying an 8 by 8 chessboard with 8 bishops.
I tried a 10 by 10 chessboard.
I tried a 4 by 4.
Now I'm doing 4
And
by
it seems
4.
that the white takes less if it's in the corner.
Now I'm
If there's
doing
only 1 white and 99 black.
I failed in 10 times 10, so I'm trying 4 times 4.
Okay, now it's just take. Yeah, that works. Now I'm just gonna find out how. Take. I'm just gonna go. Yeah, is there anything that can do in less moves? Yeah. If you would only use one bishop at the start, it would have to cross a square that doesn't have a bishop.
Okay, let me give you guys an intro, okay? So what is this problem? You could say this is the hardest problem in the world for year 10 students and under. Okay? So whether you think it's hard or not, you know, that's what it is. Okay? And
I think it's hard.
yeah, and I guess if you can sense that it's difficult, then that's a skill, that's an important skill for mathematicians. Okay? What makes it hard? Well, there are lots of things that make it hard, I think, but a lot of it you won't necessarily be able to tell until you've solved the problem. Okay? But as mathematicians, it doesn't really matter how hard the problem is. We can still basically solve it on its own merits. Yeah? Okay, so what makes this problem hard? Well, one thing that might make this problem hard is there's 100 bishops, yeah? Okay, you'll never be able to keep track of 100 bishops at the start. Does that make sense? Okay. You probably won't even be bothered to move more than 10 of them, yeah? So what mathematicians do, okay, is they find the easiest version of this problem, or sometimes the hardest version of this problem that they can solve, yeah? So a problem I propose to you, okay, is
There are 4 squares on the chessboard and
4 squares on the chessboard, 4 by 4, there's 4 bishops, all on the white squares. At least one of the bishops is white, at least one of the bishops is black, yeah?
That's kind of normal because there is supposed to be 4 bishops.
Yeah, there's actually 4 bishops on the actual chess, but there could even be more, yeah? But
Yeah,
the
but
actual
there's-
chess is 8 by 8.
Yeah,
But in actual chess, you don't have 4 all on the white squares,
and
right?
8 times 8 is 54.
Not.
No, 64.
50. Wait, no,
64.
Alright, you guys are embarrassing. Okay, so,
6 times 9 is 54.
yeah. It's funny, I remember
69.
someone said 6 times 9 was 56 in year 7.
But 8 times 8, 8 times 7.
Huh?
8 times 7 is
9 times
Yeah.
9 is 81.
No, I remember that because they got 99% on the math test, and that's the question they got wrong, okay?
I accidentally said 8 times.
Yeah.
Wait,
I
does that
accidentally
mean
said-
each question was 1 7?
Yeah.
You know I accidentally said 8 times 7 was 54 instead
Does
of
that mean there were
distance.
100 questions?
Shall we don't count. Okay, be quiet.
Does that mean there was 100 questions?
Yeah. Okay. Okay, so can you tell me the answer to this question if the number 100 was replaced by 4? Okay, so I'll give you some time to do that. Hopefully by the end of the day, I'll show you how the most difficult problem in the world can actually be solved quite simply, just one step at a time, okay?
I don't know how the bishop is so
So by the way, the person who won this competition won it by solving question 5. Then no one even tried question 7,
And I
okay?
put my,
The person who came second, they came second by getting a little progress on question
I
6.
put my bishops anywhere.
Yeah, they have to be on the white squares though.
Oh.
So nobody even solved question 7?
Nobody except for him.
And we solved it in class,
No, like, nobody.
in the test.
Yeah, nobody.
12 knocks is a lot of knocks. And he kills the other bishop for the number 4. 4 squares. 1, 2, 3, 4, 5, 6, 7. Also, if there's only one black and all 4 whites, or the other way around, then that means there must be exactly 8 moves.
If they could only be bishops.
At least 8 moves.
At least 8 moves.
You don't think it's 8 anyway? On those, like a couple. Oh, a cup. Like,
Do you want a cold one?
oh no, I just need
Wait.
something like that. Okay,
You want the cup?
Cup.
couple for
Yeah, 8. If there's one that stands out to the other ones, then there has to, and it's a 4x4, then it has to be 8 moves. Well, if it's in the corner anyway.
so let's say 4
Yeah, 8
Really?
moves.
8 moves?
how 8 moves.
He said it was 8 moves. He said.
Wait, 1, 2, 3.
Just don't get like at the very end when there are 2
Yeah,
bishops. One's still gonna be on the other color, so and bishops can't cross colors.
Wait, do they take turns moving?
No, you're there's only one person playing.
Oh.
You
So
just
you
can't.
get to choose which ones move.
Yeah, you just can't use a white bishop to kill a white bishop. Because that would be senseless, Ernest.
Wait, but
I
it's
know.
impossible. If the bishop's on black squares.
No, because like what I was thinking was, like, if black moves, usually in chess, when black moves, white moves after.
Yeah. But
Wait,
we don't have that problem here. They can move in any order.
wait.
So
Does that mean like you just do all the bishops on black except for one?
Wait.
Yeah.
Wait, but the bishops can move away from that bishop, right? No, you move it. You move.
No, they're on the same team. You know, it's not like they're trying to avoid getting captured.
Oh.
yeah, 8 moves. 8 moves if it's a 4x4.
Yeah, it's like helpmate.
If there's only
Wait,
one,
so if they can capture the bishop, but that's the only bishop on that team left, they won't capture it? The only thing I'm thinking of right now.
yeah,
It's kind of weird because they're in a team
Because you said at least one has to be black. So on the black. Wait, do you mean on a black
if it's a
square
4x4,
or on white square?
What's on white square?
So you said at least one of them has to be on the black.
No, at least one of the bishops is black.
Oh,
They're all on white squares.
then okay then.
if one of them is black and all the rest are white, in a 4x4, then it'll take 8 moves.
How
That's
many?
what it got. 8.
Wait, only one black?
If there's one black and all the rest are white,
Okay.
then it'll take 8 moves.
4 times 25, 8 times 25. No,
And
that's not how you do it. That's not how you do it.
And then
So,
W.
4x4 the earliest I've got is 4 right now. 4 moves.
For the 4x4.
4 moves.
4.
I haven't thought of anything yet. They have to kind of be on the same diagonal.
Wait a minute.
Wait, can you put the bishops like where they are? Like, can you place your like? Can you place it down?
Can
like-
you place it down?
Like, can you place the board down?
Oh, I mean, so if you want to show that the least number, right? That means for that to be the least number means no matter how the bishops are placed and how many of they are, you have to be that number has to be able to finish it off. Yeah.
So basically, the dark bishop could kill all the white bishops.
Yeah, it could be one dark bishop kills all of them, but that'll show that number's
But you
enough,
have to
right?
be on the same diagonal.
But to show that that's the least, you have to come up with a situation where having less moves is not enough. Yeah.
Wait, but they have to be on the same diagonal, right?
So it has to be at least 8.
2, 3.
Okay,
4
by
maybe
4.
I think I got it.
Yeah.
4 by 4, I
maybe
think
it
I got 3.
At
3.
least 8.
So like capture.
Yeah, but that might not work for all the cases, yeah?
Yeah.
So
I didn't think it's
why
at least
I
8.
got, 8.
Wait, let me think.
Possibility.
4 times.
So it's to be at least 8.
No.
Okay. If these two
I
were
got
dark
8 for the 4x4.
and the
How?
others were all white.
Yeah, 4x4.
1, 2, 3, 4, 1,
Can I have a
Not
look?
2x2. 4x4.
How'd you get 8?
2 by 2. 2, 3, 4, 2, Four,
Yeah.
one. Okay, to the final two.
2 by 2 is a bit.
What does that even mean?
2 by 2.
So like you can go here.
1 meter.
Well, why is it going there? You only have 4 bishops.
Yay, okay, that works.
The very last.
At
It's a
the
4 by
very end,
4.
the white actually
Yeah, with 4
wins.
bishops.
The very last battle.
No,
So the
actually,
4 by
black
4 have
wins.
4 bishops.
The very last
How many does yours have?
8.
Why does it have 8?
The very
4 bishops.
Oh.
8 is like every square's got a bishop.
why.
Oh. So half the white squares. So one
if
quarter of
these
the
squares
whole
are
thing
dark,
has
look at
bishops.
what?
Oh, I see.
They just go suicide in this part, and when you go to the last one, this one kills this one, so
I'm
dark
gonna get my mouse.
kills light, and the light kills the dark, and then the dark kills the light. And then it gets finished. Or, okay, I just thought of another one. Okay. This one's a bit suicidal. If the bishop had knight powers and could jump over pieces, he could kill every piece in its path. Here. This one's gonna be the dock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then it just keeps on going. Look.
Oh.
The dock
Oh yeah. Why can't the for the 100 by 100 the thing? Why can't they all be on one diagonal?
They can't.
Yeah, they can.
That's exactly what it is.
But that's the easiest possibility. What about the hardest possibility?
Like
Okay, so all of them are on the edges of the board. One is in the middle, and
No,
they
we
are
need the
not
one with the
connected.
most possibilities.
No, the one with the least number of moves.
No, but it says for any position, the least number of
Oh.
moves to make sure that there's only one bishop on the board. So it has to be the one that includes the most. That's the answer.
So does every position have to be the same amount of moves?
No, like the answer is the one. Is the position that has the most amount of moves, but it still has 100 bishops all on white squares. So like basically,
What about this? So these two are dark, and they just keep on killing suicidal. At the very end, this dark kills the light, and the light kills the dark, and the dark kills the light.
That could work.
Or you could just keep on going.
but it is that the position that gives the most moves. We need the one with the most, not the least.
The most moves.
Yeah.
So it takes the most moves to get all the bishops done. To get all the
Is
bishops.
the answer.
Okay, I got this. So, because in 100 by 100, there's going to be these squares as well surrounding it. It just circles these squares, like what I said, 1,000,000 times. And then when it goes back, it just kills all of that, and then yeah, finished. It's basically losing a tempo.
In this game, I think you need tempos to save moves.
Okay, let's go
Wait,
5
but
by
does it
5.
have to work for any color as well?
Okay, so let me give you an example of an argument, okay? I just want to show you what we're trying to talk about logically, okay?
So you have to go through these. Yes.
Okay, so look at this board, right? This one is 4 by 4, yeah? Oh crap. Why is the last one so bad? Okay, so imagine there's a black bishop here, black bishop here, black bishop here, and a white bishop here, yeah? Yeah?
Yeah.
What's the smallest number of moves I need for this to end up with only one bishop?
Three.
3, yeah? It just kills all of them, yeah?
Yeah.
And why can't you do it in any less?
Because could you do it in any less?
Could you do it in less than 3?
Yeah. It's
Why
gonna
is there
waste
3
moves.
pieces?
Huh?
Because there are 3 pieces, and
Yeah.
in that position, you don't waste any moves.
Yeah, so you can't kill more than one piece per move, right? Yeah?
Yeah.
You see that? You have to use at least a move to kill a piece, yeah?
Yeah.
You can't like do this like shadow magic where it's like kill the 4th one and then the 2 I'll die on the way. Like you can't do that, right?
Shadow magic.
Okay, so you have to take a turn to eat the bishop, yeah?
Also, there has to be at least 99 moves.
So-
This one's my successful one.
Yeah, so did you hear what he said? So he realized the idea works for 100 as well, yeah? There has to be at least 99 moves, yeah?
Yeah.
And so this highlights what the point of doing this is. See, we're doing 4x4, but we can still make realizations about the 100 by 100, yeah?
Yeah.
So we need at least 3 moves here because there's 3 things to capture, right?
Yeah.
And we can do it in 3, yeah? In the general, that means we need at least 99 moves, yeah?
Yeah.
Okay? Another thing is, so that means we need, so the answer has to be 3 or more, right? So the answer whatever the answer is, it can't be 2, yeah?
Yeah.
Right? It can't be 1, yeah? Okay. So we got a what's called a lower bound for the answer. That makes sense? A lower bound.
Nope. The dog could just go in a trail to the very end. Wait, so for the 100 by 100, does it have to be any position that it has to get the same amount of moves?
Hmm?
Does it have to be every position that has to get the same amount of moves?
Yeah, so the problem is, what if you change the position? Can you still do it in 3, right?
Yeah.
Okay, so let me show you another position. So let's pretend...
Well, all the free bishops and stuff there, the
If there
free
were-
black
if
bishops,
there were-
then if you were to go to any
Yeah.
other square, then you can't
Yeah.
you can't stop that.
See, and this is really how maths is done, okay? It's done with sort of these cases in your mind, yeah? So that you can always test your ideas on actual things. Does that make sense? You never just go to the problem and be like, oh yeah, it's probably 150, and then just try to prove it for no reason. You know what I mean? That's stupid. Okay. It has to depend on your understanding of the game. Yeah. Okay. So let's pretend. So this one, let's say that one's no longer there. Yeah. Okay. And let's say it's here instead. Okay.
Yeah.
So it's a black, black, and there's nothing here now. Okay.
Oh yeah, I don't
Then
think
it'd
you
be
can.
4.
Then it'd be 4.
Okay, but I want you to
Okay,
understand why it's 4. If it's 4.
5 is possible, but you can do it in 4.
Really? I did in 5.
You can do it in 4.
Okay, so if it's here,
Oh yeah.
okay, I want you to explain to me, okay? So is the answer for this case, is it 3? Okay. And if it's not 3, why it's not 3? Okay.
It's not 3. It's not 3.
It's not 3,
It's
and it's
4
4.
because like
For it to be 3,
because the other
for it to be 3, that means
Lights
all of the
flicked.
pieces have to connect.
my eyes.
Have to, like, if you get one piece, then you have to be, and then you have to get another piece, and then you have to get another piece. But with bishops, like, if they go somewhere and take it, and then take another piece, if a different piece, like,
The lowest amount you can get is if, like, every move you do captures a bishop.
Which is 3.
If there were a space
that
Yeah.
needs you to be going up by
Yeah,
1.
yeah, because the bishop's
But
out
if
of the white bishop's vision.
Okay,
I
so
have to go back
if
to
you can do it in 4 moves, yeah,
Yeah.
that shows the answer can't be more than 4 moves, yeah?
Yeah.
Okay? But we still need something else to say why you can't do it in 3 moves, and you have a good reason, okay? But you have to make it what's called rigorous. Rigorous means airtight, basically, okay? So like it's indisputable. So if you can do it in 3 moves, as you say, Gabriel, you have to capture on every move, right?
Yeah.
Okay, so that's a very good observation. And so can you explain to me why you can't capture on every move?
So, if you were to capture the first 2 bishops at the top,
Yeah.
you would need to go. You would need to, since it wouldn't be the last bishop wouldn't be in your line of vision, so you would have to go somewhere that you can see the other bishop, and then you could go there, and then you could take the bishop.
Yeah, so we don't really worry about then you could get the bishop, yeah, because it's already not capturing, yeah. So yeah, so one simple way to explain it in this case is if this is a white and these are all black, you literally have if you have to capture, there's only 2 possible ways to start the game, right? Either black captures this or you capture the black. But if the black captures this, you lose, right? Okay. So then you have to capture the black, right? And then you have to capture the next black, right? And then you can't capture the last black in the 1 move, yeah? So that shows it can't be 3, yeah? Another more abstract idea is that anytime you capture something, you have to stay on the square that you captured on, the thing on, right? So that means if none of these 3 things are in the line of sight of this bishop, then they still won't be after any captures. Does that make sense?
Yeah.
So this could actually even be more complicated. This could have like white, black, black, white, 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 black, black. But you know that they'll never end up on this diagonal, right? Because to capture, they have to actually go to that square it's on. Yeah? Does that make sense?
Yeah.
So if at the start none of this is in this diagonal, then at the end of all the captures, none of them can be in the diagonal either. Does that make sense?
Yeah.
Because to capture it, you have to actually occupy the square it's on.
Yeah.
So the squares that have bishops are going to be among the squares that already had bishops. You can't have a square that didn't have a bishop and end up with a bishop. Because if a bishop goes there, it couldn't have captured anything, right? Does that make sense?
And even if you move the black bishop into the line of the other bishop, it still wouldn't be capturing anything.
Yeah. Yeah, so if you just moved it there, you already lost, yeah? Okay, so now we know the answer is at least 4, yeah?
Yeah, I got 5.
Okay.
It's 5 if you move the one that's close.
It's 4 because you can.
I know it's
But if
4,
you
but
move,
I got 5 when I tried.
Well, you can move the bishop like how far you want. It just has to be diagonal.
At least my try was close.
You're also playing with your feet.
A bishop is not on.
Okay, so
Knight.
so I want you to think of a configuration, okay, where it does. So the question is the answer actually 4, okay? So for the answer to not be 4, you have to think of a configuration where it takes 5 moves to kill everything, okay?
I have it.
Oh, I have one.
I have the 5 move one.
What do you have?
So this one.
Yeah, you
Got
can
5
go 5
moves.
minutes freeze. Yeah, I'm gonna do 5 minutes freeze.
I got 5
Just
moves.
Just move into the empty square.
Move
Take
this to here.
I did 5 moves.
Oh yeah,
No, your thing doesn't make sense. They have to be on white squares.
So look,
Move
ready?
this to here.
So
Okay, alright.
right here.
How's
Okay,
my
ready? Look at this.
Oh, also, in the shapes
Go
there's a
here,
circle, so you don't need to draw the
and then
circle.
you
How
go
does
here,
mine not
two,
make
right?
sense?
And then you go here, which is
Does
3.
this look
Then you just go back
complicated
to the place you just captured.
to understand?
Here,
That doesn't
3.
make sense.
4.
So it looks
Oh, wait.
complicated to understand.
No, it doesn't work.
Or
Okay, so I'm
Complicated.
gonna suggest putting 3 black bishops like this, yeah? That makes sense?
okay.
And the white bishop's in the bottom left corner still, yeah? And you're trying to prove, okay, this cannot be done in 4 steps, yeah? So, can you explain to me, I'll give you a little bit of time to do this, why this can't be done in 4 steps?
They're not in the same diagonal.
You can't say one sentence and get away with this, okay? It's not that simple.
If you to maximize, to minimize the amount, you have to take it if you can. So then you have to take the one in the corner, and then you have to move it to so you can take another one, and then you have to move it again to take another one.
Yeah, that's good. One. So that would be done in 5 minutes. Okay. You can't do it. Got it.
So to minimize the chances, you have to take one
Got it.
as soon as you can. So you have to take the one in the corner, then you have to move it so you can take another one. And then you have to take it, which is 3 moves already. And then you have to move it again so that you can take the other one, which is another 2 moves.
Oh, wait.
Yeah, but you say you have to, but that's assuming you went there already, right? Like, what if you had some cleverer way to get there first? Like, how do you even know which one you have to take first?
Only one that you can see, and you can take one in the corner. The lowest one I've got is 5.
But do you have to take it on the first move?
No, you don't. Then if you don't move it, and you keep it like, you put it on the diagonal right in front of it,
Hmm.
then the dark bishop can take you.
Hmm.
For this particular move, for this particular position, if you don't take the other one in the corner, then it'll take 6 moves.
No, it doesn't have to take 6 moves. It will take 5 moves.
Well,
so like if you take the one in the corner,
and then if you don't take it, then it has to be 6 moves.
Yeah, or you can even, it can be as many moves as you want if you just keep on circling two squares.
At least 6 moves if you don't take the one in the corner.
Hmm.
For the first move, you can either capture or move. We can assume you can capture because nothing else you can do.
I'm gonna try to find a way lower than 4.
Yeah, you have to get back to another one, which will use another move, and then once you capture it, you have to get back
that
to
piece. Wait, so you take that piece and you move it somewhere so you can take that piece. That's another 2 moves, and then you have to do that again, which makes 5 moves.
You take the corner.
But if you don't take the corner, then 6 moves.
Well, okay, so you take. Wait, you can move the other bishops as well. Can you?
Yeah.
You take the
yeah,
corner.
but that also takes 5.
That would also take 5. You take the corner, and if you let it, so if you go back and then take the one.
If you're thinking
next
that
to
you
the
could
corner,
do
then
this, then that would still take 5.
Yeah.
1, 2, 3, 4, 5.
If you
Still
were
take
to
5.
if you were to move this one there, and then you were to go back and take that one, you still wouldn't be in line inside for that. So you would have to go back and then go in.
So that's why it has to be 5 or more.
I also got one for 6. You take the one that's right next to you. So 1, 2, 3, 4, 5, 6. I'm gonna try get 4. I'm gonna try getting 4 moves.
I'm trying to get it lower than 4 moves.
Can you even get it in 4 moves? No, because if you get them all in a diagonal, they'll take 2 moves. And once you
The
take
only
all of
way
them,
to get it under 4
and
moves
once
is
you
to get
take
it
all
3
of them,
moves.
then that's
I know,
3
so that's why I have 3
moves.
colors.
3 plus 2 plus 5. That's the
Stayed on my
That's
moves.
the earliest thing you can do it and confirm. Okay, so what's going to be?
Okay.
We already know how to do 3 moves.
It has to be
Really?
5
So
moves.
we need to work out on the higher moves instead of the lower moves. Because if we're
Well, you
doing
could
lower
actually go
moves,
infinite.
we have to do the least number of moves that will guarantee.
Uh-huh.
Oh, look who's that? Nathan's coming.
Hello, Nathan.
Nathan's coming.
Level 14.
Nathan Boo.
Level 14.
You could
14.
just circle.
Nathaniel's coming?
14楼.
Nathaniel.
Nathan Goo?
Nathaniel.
The guy from your black
Not
school?
Not Nathan Boo.
Level 14.
Nathaniel.
hell?
Is it that guy from the basketball
Oh
high
no,
school?
Nathaniel's coming.
Oh my god, he's coming.
What about Nathaniel?
Wait, move this space.
Is he not called Nathaniel? Nathan Goo. Nathaniel.
His name is pronounced Nathan.
Nathaniel. Nathaniel.
His name is definitely pronounced Nathan.
You'll learn, Dennis, that it's not good to play with people's names.
Okay. Oh no.
You know it's okay, bro?
How to make him? I got my bishops. Let's do this.
It's going to be so small. So you can barely see it. Yeah, so 5 moves.
Yeah, I don't think you can get it over 5. I don't think you can get it over 5.
Over.
I don't think you can get it to be 6.
How? You just move one by one.
It's impossible to do under 4.
It is. You can get 3.
How?
Wait, isn't the pattern correct? Okay, let me show you how to get 3, okay?
This is how you get 3.
Where you get 3?
Nathan from that school?
So this is how you get 3.
Oh, it's the glass shattering.
2, 3. Number 3.
The vision can't be all the same.
Here's your scratch paper. Look at this question, okay?
They're not. This is black. This is white, white, white. Goes to black, takes the white, then takes the white, and then takes the white. That's what 3 moves.
Oh yeah.
Okay, I'll give Nathan 2 minutes to kind of react to the question, and I'll kind of talk about the next thing, okay?
Okay, so if you get 6, you get 3. If you get 5, you get 2.5.
By the way, Nathan, you know Gabriel, Ernest. You know Ernest already. Gabriel, and then Michelle. Okay.
So what if it's just an essence of like take. What are you going for? 100.
Pretty sure it can't
Yeah,
go
but
over.
what if it
I'm
like
pretty sure it
pattern
can't go
like
over 5.
what if the pattern goes like like this pattern takes
Pretty sure it can't go over
oh wait
5.
The answer to the question is over one move.
takes so
I mean for the 4x4.
Oh.
I'm pretty sure it can't be over 5.
It's over
if
one
you go
move.
2 it won't work, so you'll have to
Yes.
go with 4, which probably won't work either. And it actually works. Okay, let's ready. Goes here, goes here, goes here, goes here, goes here. And yeah, it just goes so on, and then when it gets to the last 2, it just goes takes. Oh. So now, what if it goes like this? These are like so then, this is right. And then this is right. Right. Okay, so so black can't take both. Oh yes, good. That's not easy. So then what can't take what? So they can't take anything. So take that. So we take the 4. Oh
Pretty
yeah.
sure it can't go over 5.
Oh yeah, we neutral.
Can't go over 5 for 4x4.
I'm gonna try to
What
make
about
a
the one?
smaller 100
How can
times.
it not go over 5?
I'm gonna try to make 100 times 100.
It can go over 5, but it can't go under 5.
Like this.
It can go
For the
over
4x4.
Yeah, for 4x4.
It can't go over
I need
5.
another paper. I need another paper.
Yeah.
The waste of few views as well.
For minimal.
Minimum, but it can't go over 5. You can.
I'll give Nathan 3 more minutes to read the question and think about it, and then we can talk.
Well, you can move that over there.
You think I can make 100 times 100 square?
That's right.
You think I can make 100 times 100 square with this?
Is not coming. Winston.
Hello?
There's Winston.
Okay, so I will show you the thing.
Winston?
No, it's Winston.
Level 14?
There's Winston.
Level 14?
Winston.
Okay, I just finished my presentation. Bye bye.
Winston's coming.
Oh wait, we need more chairs. How many chairs? More chairs.
Is Winston your friend?
I guess he's sitting in the middle.
Is everybody Asian?
I
Can you
moved.
move your chair a bit?
I'm just not sure about.
I just need to put the chair in the middle.
Okay. I'm just not sure about Gabriel. Is he? Wait, are you Asian?
Yeah.
Okay, then we're all Asian.
With the Asians.
Asian.
Wait, is your dad Asian, Michael?
I think.
A is for average,
Yeah.
B is for below average, C is for can't eat dinner, D is for
No,
don't
B
come
is for bad.
No,
A?
A is for average, B is for Asian.
No, A is for average, B
A
is for
Asian.
bad, C is for crap, D is for dog shed. I don't know about
He
E.
said a bad one. He said a bad one.
Okay.
This way.
E is elastic man.
No, A is what?
Yeah, that's stupid. No.
A is for apple.
A is for average, B is for below average, C is for can eat dinner, D is for don't come home, and F is for find new family.
What about E?
Oh, there is no more E, remember?
No, E is emotional damage.
Okay.
Emotional
Then F
damage.
is fly away. And G. There's a G. G is gonna be get away from me.
And H is for
Help.
home. Home is gone.
No, homeless person.
And then after H is I is for igloo.
Wait,
home.
Imagine
Yeah.
dying.
Imagining virtual
Jumpy
reality
diapers.
die.
Jumpy diapers.
And then J.
After
K
I
is
J.
for kill you.
He's from full green.
L is for loser.
Alright, guys. Focus on this. Okay?
Luck. Good luck is that. Luck.
Good luck is that.
Hi.
Wait, no, that's for Winston.
Yeah, that's Winston.
Hi, Winston. Hi.
Hi.
Winston. Hello, Winston. Hi,
It's Winston, not Winston.
Winston.
Yeah, Winston.
Who is Winston?
Winston.
Never seen that guy before.
Yeah, you're clueless.
Never seen that guy before.
Now show me
Where
what
can he
can
get
be done in over 6 moves. I mean,
Okay.
over 5 moves.
I will show
Show me your possibility.
Okay. I got it.
Show me your possibility.
You think I can make 100 times
Yeah, I'll just throw a bridge.
Alright, guys. So we got a full house today, huh? Winston, have a look at this
Well, I
problem,
didn't
okay? I'm gonna explain a
Okay,
little
yeah.
bit of it soon.
What?
You think I can make 100 times 100 chessboard
Hello?
with this square?
Aiden, welcome. Can you hear me?
Yeah.
What? That doesn't even make sense.
Because
Why can't go out of the board?
You think I can make 100
Okay,
times
like
100 square with this square?
Goes back here.
Okay, guys, listen up.
Goes here.
You think I can make 100 times 100 square with this square? This square.
Yeah, you use my screen.
Guys, listen up. Listen up. So this problem, okay, I've already said this already, but this problem is the hardest problem in the world, okay, for year 10 students in law, okay. So if you look at this problem, okay, we had this tournament of towns in Australia. No one could solve this problem, okay, and someone who solved like an easier problem won the entire thing, okay. But no one solved this problem. It's the hardest problem in the world for year 10 students in law, okay? But what I want to show you is it doesn't matter how hard the problem is, you still approach it the same way, okay? And you should probably have a sense that it's going to be harder than other problems, and then it maybe take you a bit longer, but you still solve the problem the same way, but with just more patience, okay? So one of the things I showed you what you can do is you don't have to accept the problem as it is, okay? So in some sense, the problem is difficult because it's impossible to solve it as it is in some sense, okay? So what we want to do is we want to change the problem so that it's easy for us to solve, okay? And the first thing that we did to change the problem is instead of having 100 bishops, okay, we only have 4 bishops.
Yeah, and a
Okay.
4 times 4 square.
And we have a 4x4 chessboard. Okay, so you have a 4x4 chessboard like this. Okay, You have a 4x4 chessboard like this, okay? And instead of having, you know, a random mix of colors, we just have one white bishop and 3 black bishops, yeah? Okay. So there's already some things Nathan missed, but basically, if we have just like 1, 2, 3, 4 bishops all on the same diagonal, yeah? It's gonna take at least one move to capture each bishop. Yeah? You guys know how to play chess, right?
I know.
Yeah. It takes one move to capture each bishop. Okay? And so it needs at least 3 moves to end up with just one bishop. Yeah? Okay. So the answer for 4 bishops is at least 3, but you don't know if you
Is it
can
two?
do huh?
Could it be two?
So it can't be 2, right? We explained that.
It moves to where the black bishop can find it, and then the black bishop kills it, so it becomes draw. Then
Draw. No. Like the game has to end with 1 bishop, yeah? Okay. So you need at least 1 move to capture each bishop, and you need to capture 3 bishops for there to be 1 bishop out of 4 remaining. Okay.
to be the 4x4. So
Okay. So one thing you could do is you could actually draw this configuration where you have. So you have your 4 bishops like this, okay? And this is your white bishop. So that's your white bishop, okay? And you have 3 black bishops like that, okay? So can you prove to me that with this configuration you need at least 5 moves to end up with only 1 bishop, okay? I'll give you 1 minute to think about this.
Dun dun.
Shh. Okay, prove it. And I'll give you an example of what a proof is, okay? You stop drawing on yourself. Focus on the question, okay? Too loud, okay? You're not even doing the right thing. Okay, so look, the idea we had before was, so remember, if we can do it in 3 moves, it means we have to make a capture every move, right? Okay. So if we want to show this can't be done in 4 moves, okay, what does it mean? So obviously it can't be done in 3 moves, right? And the reason is because the only thing that can capture is the red thing. The red thing is like it has to be the one doing the captures until the very end. Okay. So Oh, and on the first move, the red thing can't capture anything, right? So you're forced to waste a move, not capturing stuff. So you're already on to 4 moves, yeah? So even after you capture everything, it's still going to be 4 moves, right? Okay. Now, I want to show that you can't actually even do that. So it has to be 5 moves or more, yeah? So for the red thing, to move and then capture, right? Can you see that means it has to end up at one of these 3 squares in the first 2 moves? Does that make sense? So for example, I can move here and then I capture this one, yeah? Or I can move here and I capture that one. But it doesn't really matter where I move, I just have to move so that I have to capture one of these on the next move. Does that make sense? Okay. Huh?
And what if it just goes one to the left? So it goes to this one.
Yeah.
And it captures the one below it, and then since it's also on the same diagonal, it captures the one above it.
It captures the one above it. Yeah, you can do that. Yeah.
It does 3 moves, and then it has
Yeah. So the problem now is it's stuck
So
here.
it's 5.
It's stuck here, and I can't get to that one in one move. Does that make sense? So the reasoning is the same anywhere. So okay. So obviously, if it ends up on this square first, right? That's not attacking any of the other ones, so you have to waste a move to get onto this diagonal.
Basically,
right?
if it's that square, it's basically the same as the square that you. If it's on that square that you just pointed out.
Yeah.
Basically upside down, same thing.
Yeah. So can you see? So then it can't be done because if it goes here and it has to capture, then it has to capture there, and then it can't capture on the next move. Yeah. And it's the same for every one of those 3 dots. Why is it? Does that make sense? And so that means that's the only way to do it in 4 moves, right? Because it has to waste one at the start, and then it has to go capture, capture, capture to get 4 moves. Yeah. But we just showed that if you move at the start and capture something, then you can at best go capture, capture, but not capture, capture, capture. Yeah. Okay. That makes sense. So this needs at least 5 or more moves, right?
It can do in 5.
Can you see how to do it in 5 moves?
Yes.
Alright, how?
So
You can move it here like you said, right?
Yeah.
And then you take this one.
Yeah. So that's 2.
2 moves, yeah?
3.
You take that one.
The other one.
3, yeah?
Then 4, it goes back, and 5, it takes.
5 it takes, okay? They can do it in 5. Okay. So now I want you to see, no matter where the 4 bishops are, and no matter how many of each colors are, can you see you can take it in 5 moves? Okay, so this is a little bit trickier because now you have to imagine lots of different cases. Okay, so this one only has 1 white bishop, or the red thing, right? But it could have like those 2 be red. It could have a lot of different things. Yeah. So can you explain why? So no matter what the colors are, it can only take like you can use 5 moves.
Because on the 4x4, there's so if you were on a diagonal, there's only 6 of the squares you can go to, not including yourself. So that means if you went on, and so that means there would be 5 places you can go, and if you cut.
I mean, sometimes there's less, right? There's like 3 here.
There's 7 places.
Yeah. I'll give you a little bit of time to think about it. So I'll give you 3 minutes to come up with an explanation, okay? Why no matter where the bishops are and what their colors are, you can get in 5 moves. Does that make sense?
Okay.
If it's possible that you could get it in 3 or 4 moves,
No, it's not you can do it in less. It's you don't need more. Yeah. So you don't need. There's nothing where you need 6. Okay. So you want to show no matter what it is, you can use 5 moves to finish it. Yeah.
Yeah, that's what I was saying.
You guys come up with anything?
I think I came up with something. Wait, what if all the squares were filled with dots? It would have to be more than one. So like, I came up with like so if you take it takes one. If you take something, it takes one move, and like, and if you can't take something, you gotta move to it, which takes a move, and then take it, which takes 2 moves. So then, first you take the one in the corner, and then and you have to move to the other one, like right next to it, and then take it, which is 3 moves already, and then you have to do the same thing, which is 5 moves.
Yeah. Okay. So maybe we need to understand what's okay. First of all, that's specific to this thing. Okay. We want it to work for anything. Okay.
So
That doesn't prove why it can't be 6 or more. That only proves why.
So you move to.
It can't be lower.
You can move to somewhere that the piece that you can see a piece. You take it.
Yeah.
So that would be 2 moves.
Yeah.
Then you move to another one.
Yeah.
And you take it.
Yeah.
So that would be 4 moves.
Yeah. So that's kind of that explains what 5 moves actually means. Okay. So think about you need to take 3 things to get to 3 moves. Yeah. So you're forced to do 3 moves no matter what. Okay. Another 5 moves it's almost double 3. Yeah. So what you're really doing is there's 2 things that need to be set up before it can be taken, right? Okay, so or sometimes you want to waste more, but you don't have to because the bishops are all pretty close to each other. Yeah. So basically, if you can set this one, if you can set it up in one move, right, and then you set this one up in one move, okay, yeah, and then you can just take them all, right? Then that's 5 moves. That make sense? Okay. So you're allowed to use 2 moves to set it up, and then you have to take everything. That make sense? I'll show you how you do it. Where you just kind of.
Or you can just take a few and then use 2 moves so that you can take the other. And then you think that's not.
Yeah.
With a 4x4, it can't take
Try to.
With a 4x4, it can't take more than 2 moves to take a piece.
Yeah. So see what you can do. Okay. For example, you can do this. Okay. You can put this thing onto the main diagonal over here. Yeah.
Yeah.
And then you can do this thing and put that onto the main diagonal over here. Yeah. So then you use 2 moves to set up everything on the diagonal. Yeah. And then we know that when it's on the diagonal, it takes 3 moves to clear everything out. That makes sense?
Yeah.
Because they're all there, they're all next to each other. They can just keep taking, and you're finished. Okay. So we can set up with 2 moves.
Because no matter what, they're all going to be connected to the main diagonal.
Yeah, exactly. So no matter what, there's going to be something on this diagonal, right? Like, it's going to be on one of these diagonals. Yeah. Okay. Yeah. So, I mean, there are a few issues with this. Okay. So what if? I mean, it's possible, for example, that there's nothing in the bottom corner. Yeah. There's like nothing there. Okay. And it's possible, say, there's nothing there. Yeah. Okay. And then we have all 4 on these diagonals. So maybe we have like black here, black here, and white on the other diagonals. Like here and here. Yeah. Oh, actually, to make it more difficult, you probably want nothing to be here. Put that not to be in
If
here.
you made it like that, then it would only
Put it here and here.
2 minutes, right? 1,
And
2,
move the one in the middle.
1, 2, 3, 4. That's 4 minutes.
Okay, you move the one over here, down the bottom. Yeah. Okay.
Then you take it.
Yeah, so how many moves does this take?
So you can use 2 moves to take the one there, and then you can take the other green piece to take your piece. And then it would only take another 2 moves after that to make one of them take the other one.
If you wanted it to
So that's 4 moves.
Yeah, so as long as it's less than 5, we're happy for now, yeah? So it's 5 or less. So here we could like just take it, and then have that one
so
take it.
if those 2 greens and the red could attack the green bottom.
Yeah.
And it takes the green takes it, that would be 3 moves. And then that green goes down and then takes the other red.
Yeah.
So that would be 5.
I was thinking the top one would
So I guess
the top red one would take the top green one, and then the other green one would take the red one. And then
yeah, so the red could take the green could recapture, right? And then they just move on and meet each other. So that only takes 4 moves, yeah? Yeah, I guess the point I'm trying to make is if they're not like within this diagonal and easily placed on the diagonal, then they have to be kind of sort of doubled or tripled up like this, yeah? In which case there's already captures. Okay. Yeah. Yeah, so this might be a nice little exercise if you have time. I mean, we don't quite have enough time for this right now, but you can consider like the cases, yeah? So, there's only, oh, by the way, if you didn't care about the colors of the bishops, do you know how many possible starting configurations there are? If you didn't care about the colors of the bishops? Like, how many ways are there of picking 4 squares from 8 squares? Chandel. Sheldon，我送他下去吗？OK，好，如果方便的话。那我正在光顾。你能等一会儿吗？OK，好。现在还是让我上去接他。也可以，就我们可能还要讲15分钟，10分钟可以吗？10分钟？可能来不及，因为他6点5到，可能会来不及。好，那我就讲5分钟，就要他下去。OK，好，那我就在楼下接机等他。好，谢谢。OK. Okay, what was talking about? Yeah, so, do you know how many ways they're picking 4 things from 8 things? So there's 8 squares in total, right? So the reason this is known as a combinatorics problem is there's a lot of combinations. Stop. Okay, so this thing we learned before you guys came earlier in the previous term. Have you heard of this number called 8 choose 4? So that's just notation. That's just a way of saying this is literally what this stands for is the number of ways of picking 4 things from 8 things. Okay? And the way you get this is 8 times 7 times 6 times 5. Okay? And then that's the number of ways to pick the first thing, the second thing, the third thing, and then the fourth thing. Yeah? Okay, but there is no ordering. You just want 4 of them, so you divide by the ways you can order it. So there's 4 ways to pick the first thing. 4 ways to order the first thing times 3. So this is 4 factorial, yeah. Okay, so that's times 1, and this number here, it's actually, so the 6 cancels with the 6, right? The 4 cancels with the 8, so it's 2 times 7 times 5, yeah? Which is just 7 times 10, which is just 70. Yeah, so 70 ways, so even 70 ways is actually quite a lot, right? So that's why a lot of the time you have to use like the symmetry of the thing to do the cases. So as Ernest was saying, like when there's 2 things on the opposite corners and there's 2 things there, it doesn't actually matter which way you go, it's like the same, right? So if you wanted to go through each case, there's 70 of them if you don't care about the color, okay? If you did care about the color, you can imagine there's more, right? Do you know how many more there are if you cared about the color? So if you have 4 things, right? There's like 16 ways of coloring black and white. So 2 times 2 times 2 times 2, yeah? But you're not allowed to have all white and you're not allowed to have all black, yeah? So you gotta subtract those 2, okay? So actually, if times 17 by 14, it's getting pretty big already, yeah? So that's kind of what makes the problem interesting, right? Like if you had to consider all the cases, the number's very, very big. But if you come up with some ideas and using symmetry and stuff, um, you can do one idea for all the cases. Okay. Okay. So Gabriel has to go, but if you want to know how the solution goes, I'll send you the video. Okay. Gabriel.
Okay.
Does that make sense? So go. Your dad's waiting for you. It's level 1 now. Alright, see you. Alright. Okay, let me get my screen back. Okay, so while you're waiting for me, okay, I'm gonna set up the screen, but so we basically solved this for the 4x4 chessboard, right? And we're not doing it just for the sake of solving it. We're trying to get ideas that we can use for the bigger chessboard, okay? Okay, so I want you to try what happens for the 6x6 chessboard while I set up the screen, okay? 6x6. Six by six, okay? Okay, let me just go to. Okay, 6 by 6, yeah. Let's say these are white squares, yeah. So what I want you to do is I want you to come up with a example of where bishops could be, right? So let's pretend this is white diagonal, yeah. So obviously if it's 6 by 6, you want 6 bishops, yeah. So can you put 6 bishops that that will show us, for example, so if we had 4 by 4, yeah, we took 5 moves, yeah. If we had 6 by 6, how many moves do you think it should be? 8 moves? Okay, actually this is stupid, but remember if you have 2 by 2, how many moves is it? It's 1 move, yeah?
Yeah.
So 2 by 2 is 1 move, yeah? 4 by 4, it's 5 moves, yeah? 6 by 6, so why would you say 9? Huh? Okay, so maybe we can try to see what it is for 6 by 6, yeah? So can you come up with an example that cannot be done in like 7 moves, yeah? Can you put 6 bishops on a square that can't be done in 7 moves? Michelle, you're too loud. You shouldn't even be looking in there. You're either solving this problem or you do something else, okay? Oh, it's crazy weather, huh? Oh, you get to choose, but they can't all be white. So you get to choose what color the bishops are, and you get to choose where to put them, okay? But you just gotta put them somewhere that you can't solve this problem in 5 moves. Or 7 moves. 7 moves. No. Do you have a pen?
I got something that has 9 moves.
9 moves?
Yeah.
Oh yeah, what is it? Where you put them?
this.
I can't see it. Which one? This one. Oh, you have 3 of each color.
Yeah.
Why? Okay, I'm gonna put a modification of Ernest one. Okay, so Ernest put. So I'm gonna do blue dot, blue dot, blue dot. Red dot, blue dot, blue dot. Yeah. So he had more red dots, but I think it's easier if we have 1 red dot for me. Okay. 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 So how many moves does this take? Well, can you see a way to do it in 9 moves first of all?
Yes.
Oh. Oh no, like it's just total movements. So, because it's not like white has to move then black. It's like literally white's like literal they're on the same team basically. You're moving all the pieces, so you can move whichever one you want.
Yeah, that's not.
Yeah, how did you do it?
So
You take the bottom one.
there's multiple ways.
Yeah.
One way is that you move this here, move this here, move this here, move
Yeah.
this
Okay.
here, and then take
So one thing that's good about that is it reuses the idea we already had, right? It's hard to come up with new ideas. Sometimes it's good to relate new things to old ideas, yeah? So if you just invest a move and make them go on the diagonal, okay, like that, then you waste 4 moves for the 4 things you put on the diagonal, yeah? But then every other move is a capture, right?
which is another 4 moves.
Yeah, but it's not really important how many moves because captures it's always the same, right? You always need 5 captures when there are 6 things, right? Yeah, so there's always 5, and then the other 4 makes it 9, right? So 5 is like your fixed thing, and however many you waste, you add it to 5. Does that make sense?
Yeah.
Okay. So then the question is, how do you know it can't be done in less than 9? Okay. So this is the argument I want to show you for today.
It was in a different position. Because it was already in a diagonal. Yeah.
That's not what I'm saying. Okay. So like, because if this situation cannot be done in 9, right? Cannot be done in less than 9, then less than 9 cannot be the answer. Yeah? So it doesn't actually matter if another situation can be done in less than 9. Okay? So all the situations that can be done in less than 9 are actually irrelevant, if that's true. Yeah? So I want the rest of this is to be about proving why this can't be done in less than 9. Okay? And actually, it's kind of cool that you can draw like a this is 5. And draw like a huge version of this. Yeah. How many squares is that? 20 by 20. Yeah.
Yeah. Oh yeah. It's just the same thing, except bigger.
You can literally do the 20 by 20.
So isn't the answer just 101?
101. Are you sure?
Wait, no, not 101.
99.
No.
Remember, 100 times 100 is the answer.
Yeah. So if this idea is correct, yeah, what would the answer be for the whole question?
Hundred.
You gotta think before you say stuff, okay? It's best not to say stuff. Okay, Ernest seems to have gotten it. So if this was 9 moves, yeah?
Yeah.
Then ... So the question is, what's 100 by 100? What's the pattern? Yeah, what's the number that goes there?
I got 109.
Wait,
So
it
Ernest?
just goes up to 4 moves every time.
Yeah. So
If you go up by 2s.
yeah. So I guess an easy way to summarize the pattern, right, is one move here is 2 times 2 minus 3. Yeah. 5 is 4 times 2 minus 3. Yeah. 9 is 6 times 2 minus 3. Yeah. So here 100 times 2 minus 3 is 197. Okay. So in the this is 20 by 20. So what's 20 by 20, you know? How many moves is 20 by 20?
37.
37, right? So this example should try to give us 37 moves, right? And then we just draw a huge one, and then we have it for 197 in the question, yeah? So once the example is big enough, the idea, if it's the right idea, there's a high chance that the idea can work for the very big example as well. Yeah.
The ones that I missed are like the top right, top left, and bottom right.
Top right. Which ones? What do you mean?
This one, and that one.
When you say this one, and that one, you mean this one?
Minus 3, you need a minus like 3 of the dots.
Oh, so yeah, like So minus 3. Yeah, so what does minus 3 mean, right? So it means sort of there's gonna be 2 dots. So when you have 6 dots and it's 9 and you're minusing 3, right? Well, okay. Well, the one that's left over, it doesn't have to count. So the 99 things that are being captured, yeah. If they all made a move and then got captured, then that would be that would be 10, right? Okay. Well, that would be 198. Okay, and then we have one less than that. Where's that one less coming from? I guess that's kind of what Nathan's trying to address. And that one less is coming from basically this dot not having to move onto the die, right? Yeah. So basically everything had to move before it got killed, except for this one. This one got killed where it stood. Okay. Yeah. 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 Okay. So I want to explain to you why. Okay, why? So in this case, it's 37 moves, yeah?
Yeah.
So I want to explain to you why it can't be done in less than 37 moves. Make sense? So it's not 36 moves. Make sense? And if you can do it in less than 36 moves, you can just waste some moves and you can say it's 36 moves, right? So I wanna suppose, have you heard of this thing called argument by contradiction? Have you heard of that?
I have.
So what I do is I assume, okay, it can be done in 36 moves. Yeah? Okay, so I assume the opposite of what I'm trying to show. Yeah? And then I show that if it can be done in 36 moves, it'll lead to a contradiction. Okay? So for example, like like how do I like if I was to argue like Michelle is not like 10 meters tall, right? It's like,
But I am not.
yeah, so I assume she's 10 meters tall, right? And then I think, okay, well, if she's 10 meters tall, then she'd be too big for this house, which is at most 3 meters tall. Yeah? And so because she's not too big for the house, she cannot be 10 meters tall. That makes sense?
Yeah, 3.
So you assume something and you imagine what would happen if that was true, and if that was true, if the things that would happen don't make any sense, then the thing can't be true. Okay? So that's called argument by contradiction. In real life, there's like lots of real life examples that aren't necessarily logical. It's kind of like, how do you tell if people are lying, right? Yeah, people are lying all the time, right? Well, let's just assume what they're saying is true, right? And you think about what that would mean, right? So like they're like, oh, where were you at 4 o'clock? And they're like, oh, I was at Muirfield, right? And you're like, oh, okay. Where were you at like 5 o'clock? And it's like, oh, I was in Singapore. And it's like, okay, well, so it took you
takes
one.
8 hours to go to Singapore.
Yeah, so it's like somehow you got from Muirfield to Singapore in 1 hour, right? Okay.
Maybe 25 hours.
Oh yeah. Oh yeah.
Yeah, so I mean, yeah, sometimes it only seems impossible, but it's actually possible, and that's like the crazy ending of some show, right? But like, the point is, they can't both be true, right? So they might have been lying about being in Milford or being in Singapore, right? So this is called contradiction.
I think they're lying about Muirfield.
You should be quiet. So annoying. Okay, so let's assume it can be done in 36 moves. Yeah? Okay. So remember, what is the significance of 37 moves, yeah? So 37 moves just basically means that, yeah, so all of the things, so there can be one thing that doesn't move, yeah, before it gets captured. Does that make sense? Yeah? But if there's 36 moves, okay, there's at least 2 things that don't move before they get captured. Does that make sense? Yeah? Because the way you get 37 is like everything moves to the diagonal. It's what wasting everything except for one thing wastes a move, right? And then the red thing goes and kills them all. Yeah? So if there's less moves, then there's not enough moves for them all to move onto the diagonal. Something else can't move as well. That make sense? Okay. So let's suppose it's this thing here, right? And this thing here. Yeah? So let's say those 2 things don't move. Yeah? Does that make sense? Because you don't have enough moves to move everything. Yeah? Right? You have basically you can waste more moves with the other thing, that just gives you less moves. Yeah? But the thing is, you have how many things do you have here? You have a total of, it's 20 by 20, right? Yeah. So you have a total of 19 blues and 1 red, right?
Yeah.
So out of those 19 things, if they all move once and then they get captured, that's like 38, right? Yeah. So 37 means one of the things didn't move. Yeah? And 36 means 2 of the things didn't move. That make sense?
Yeah.
Okay, so 2 things don't move. Let's just pretend it's those 2 for now, okay? Yeah? So it's these ones in green that didn't move, okay? Alright. But we know that the red thing has to go and kill everything, right?
Yeah.
That makes sense? And we know that when the red thing kills something, it has to occupy the square it's on. That makes sense? Okay. So what does that mean? It means that the red thing at some point has to end up here, right? Yes? Because it never moves. But you have to go and capture it. Yeah?
Yeah.
It has to also at some point end up here, right?
Yeah.
That makes sense? Okay. And so now I want you to consider, so how does it even get from there to, like, if it ends up here first, for example, right? It has to somehow go from here. Okay. And do some crazy bishop moves, right? It's like a crazy bishop moves around the place and end up there, yeah? Okay. So I want you to consider how this can even happen. Huh? No?
You're supposed to do the minimum.
Yeah, the minimum amount of moves. But the thing is, the problem is, like, okay, so I want to ask you a question here. So can you go from, so let's call this 1, right, and 2, yeah? Can you go from 1 to 2, yeah, using only captures? Does that make sense, what I'm saying?
Yeah.
So like the other blue things help you like move, like this, say this thing moves here, right, and then you capture it, yeah, and then something moves here and then you capture it, and then something moves here and you capture it, yeah. Is that possible to do? You understand what I'm saying? Yeah. So what does it mean to do it only in captures? Remember how like we're basically, if we're assuming it's done in 36 moves, okay, let's just say that each one of the other things moved once, right?
Yeah.
Well, if each of the other things all moved once, right, then you don't have any moves left to waste. You have to start capturing or you're going to lose. Does that make sense? You've already wasted all the moves you can waste, yeah? So then the only way for you to succeed is to just capture everything else, right? So in some funny way, the blues are kind of just, they're moving into the way so that you can connect the red one from 1 to 2, yeah? They're kind of just sacrificing themselves in the way so that you can kill them and then move to the square you want to move, yeah? Okay, and the question I'm asking you, is it possible for you to do that? Yeah. So I mean, one of the things that you said, so Nathan said the minimum, right? So a minimum might look like this. So if you have this diagonal here, right? Yeah. And it connects like that, right? Yeah. Can you see it's impossible? It's impossible for you to go like here and here using a capture. Okay? What I mean by that is,
There's no piece that can go to the spot
exactly, that's what Ernest is getting to. So
2 moves.
for you to go here and here in a capture, you have to get a blue square onto that spot, right?
Yeah.
Okay, but no blue spot can get on, no blue bishop can get onto that spot in one move, yeah? And the reason is, the way this is set up is there's exactly one blue bishop on each diagonal, okay? And there's exactly one square where 2 diagonals intersect, okay? And so the only bishops that can actually move here are the ones that don't move, yeah? You see that? So this cannot be the path, yeah? So that's a good start. So one thing, like Nathan, is, so when you do the minimum, is you get to see what it looks like in the simplest case, right? So can you come up with an idea for why you can't do it in captures, no matter how you go? Like, because it could be a lot more crazy than just up and across, yeah? It could do this really crazy path. You could, like this one, go up, down, across, yeah? So how do we even know for the crazy path it can't be done, yeah? So again.
You can't have a bicycle.
He's okay. So this is a very good observation. So you can't. So the thing is, like sometimes you can use a piece to make it move, but that once that piece is used, it's dead, right? So you can't use it twice, and so if you need it again, you can't do it, right? So maybe you can tell me why would you need it twice? Can you tell me?
Because if you go to that last one, before you get to the number 2,
Yeah.
you have to sacrifice 3 pieces, but you have to something like
Yeah. Do you understand what he's saying?
Yeah.
Does that make sense? So you don't even. It's not. I think it's just 2. Yeah. 2 is enough. So if you look at this path. Yeah. Just look at the last bit of the path. It has to turn at some point, right? Let's look at these two. Let's look at this. Yeah.
You have to sacrifice to get to that.
Yeah. So to get to that point, maybe something weird happened. But let's say you got to this point, right? To finish off, you have to go here and then turn, right? Yeah. But you can't because both of these purple things that you need to sacrifice, yeah, are on the same diagonal, yeah? But there's literally only this thing in that diagonal and this thing. Does that make sense?
Yeah.
So like
The only thing is that the one that's 2 spaces away from 2
Yeah.
can put on one of the purple ones and the other one.
yeah.
Yeah, but then you need to get to the one before that.
It's the same
Yeah.
you can't jump over pieces.
Yeah, exactly. So this one is used up because it you had to turn there, right?
Or you could use the one like over there.
Huh?
Oh, but then you could use that one.
Yeah.
Some pieces are not available to get sacrificed because both of the dirt moves are facing towards it. So and it's on the side, so nothing can.
Like the dirt moves would have moved there, but the dirt moves don't move.
Yeah. Don't move the don't moves, yeah. It just says don't move and then Michelle just moves it, I bet you. Don't move it. Okay. So can you see it's kind of nice? Like, no matter how hard you try to get from one to the other, you can't sacrifice more than one per diagonal, right?
Yeah.
So every time it turns, okay, so at the point that it turns, so if you look at this path, right? It tries to turn there, right? Okay. And then that uses like this one, yeah? Right? And then you have to you want to turn again. Okay? So you can't use that one anymore. Right? It tells you exactly which one you have to use because on the first one you can't move that one, right? There's always two every intersection of diagonals there's obviously 2 things that can go there, but the first thing can't move, right? So then it has to be this one that moves, yeah? But then once that one's gone, the next turn has to be this one, right? Yeah. And then when this is gone, the next turn has to be that one, right? And then when you go down here, because that one's gone, the next turn has to be that one, right?
Yeah.
Okay, it has to be that one. But then the last turn, it can't be anything because your thing can't move.
Same for if you're going
Right.
from 2 to 1.
Hmm?
Same for if you're going from
2 to 1. Yeah, it's exactly symmetric, right? Okay. So let me give you an idea how this problem is solved then, okay? So can you see that it's impossible to get from 1 to 2 using only captures, right? Okay.
Yeah.
So, but you have to get from 1 to 2 somehow, right?
Yeah.
Because they can't move, yeah? So, and it's impossible to do it with just captures, right? So what does that leave you? What possibilities does that leave you? Yeah?
with 1 not capture, which equals an extra move, which equals 37.
It's not quite 37 yet, okay? Because you don't have to use... No, it doesn't... You don't have to use all the moves, yeah? Okay? So it's a bit trickier than that because, you know, like, you don't have to waste all the moves, yeah? You can move the red thing more than once as well, right? Does that make sense? Okay. So if you can't move from 1 to 2 using only captures, yeah? Right? The conclusion is actually really sounds really stupid. It's or you have to use some non-captures, right? Okay? But what kind of moves are non-capture moves? Yeah? So you can move the red thing without capturing anything, yeah? Yeah. So you can move this like an extra time and then you capture something, right? Okay. Or you can move the blue dot an extra time. Because if you can move the blue dots more than once, then you could probably get it with captures, right? Does that make sense? So yeah, I mean, like, I guess it's kind of pointless if you could just move the red thing, right? But the point is, okay, the point is, um, you're wasting, um, so every time you do one of those moves, yeah, okay, you create another thing that can't move. Does that make sense? You know what I'm saying? So, like, we have these two things that don't move, no matter how many things you move, right? Yeah? Okay. But if you waste an extra move, right? Yeah?
Yeah.
Then there's going to be another thing that doesn't move. Does that make sense? Yeah. So to solve this problem, you're forced to create the equivalent problem. You see? Because if you get from here 1 to 2, right? Yeah. Like ideally, then you just go home and you're done, right? But what actually happens is when you go from 1 to 2, to do it, you have to create a 3. Yeah? Does that make sense? Yeah, and so you can never do it. Because every problem you solve creates another problem. Yeah. And so finally, when you do the last thing, right, you're actually out of moves. Does that make sense? Because at some point you have to do it in all captures, or you've got no more moves left. Oh no, we proved the question. We proved it can't be done in 36. Yeah, so that the answer is 37. Does that make sense? Yeah. What do you guys reckon? Hardest problem in the world. Doesn't sound that hard when you think about it, right? Or does it sound really hard? I don't know.
When you look at it, it doesn't sound hard, but when you actually understand it, it is hard.
Yeah, but it's not completely finished either. Okay.
It at all.
Yeah, but you weren't fully paying attention, so most of it's your fault. If you fully paid attention and didn't understand it, it'd be more forgivable. Yeah. Okay, so do you understand the idea behind this argument? Yeah. So no matter what, if you do it in 36 moves, you have to get two things. Yeah. But to get from one to the other, you can't do it without wasting moves. Okay. And if you waste a move, then you create another thing that you have to move to. Okay. So you're never done. Okay. And so then you're wasting a move for every little trip, and then
Until there are no more moves.
yeah, until there's basically no more moves left, and you have to get from one to the other, and you have to do it in captures. Yeah. Okay. Do you guys understand that?
Yeah, kind of.
It's not easy to understand, and it's not necessarily correct to say you'd understand it completely. Okay, because there's actually a lot of cases. So, can you think of a case we might have missed that could be different? So what are we actually claiming here? You understand what we're claiming? Even though I said 1 and 2 for those two dots, yeah? I'm actually saying no matter what 2 points you take, yeah? You can't move from them in just captures. Right? There's not just these two, it's any 2 points. So like I could take this point here and this point here, right? You know what I'm saying?
Yeah.
So can you think of 2 points that might be a little bit different than what I just picked, or maybe they're the same, yeah? Or at least if they look a little bit different. Can you pick 2 points for me? Just pick any 2 points you think might not be covered by the arguments that I just gave.
Usually just the yellow one. Probably just the same. Because it'll just hit a wall and then bounce to hit the other one. And then nothing can hit that place on the wall without 2 moves, which you can just do earlier.
Okay, so Ernest reckons these 2 yellow ones are not going to be a problem, yeah? Okay, maybe so. I'll give you 1 minute to come up with 2 things that you might think is a problem, or at least the. Okay, I'll give you a minute, and then I'll ask each of you to give me two dots. I'll even color code them your favorite color, okay? And then we can solve them.
Don't have it.
If you don't have a favorite color, oh, I guess you just say it's blue then, like I do.
You just say color code.
All right, so your time's up. So what are your 2? You pick 2 points.
The one in the middle, top and bottom.
Okay, and what's your favorite color? Purple. So like here and here, yeah. All right, Nathan, give us a color and 2 points. Oh, I have extra colors. I pay for this. I pay for this, so it gives me baby pink. It gives me
so pretty. I love this color.
it gives me mahogany.
What the?
It gives me aubergine.
Hey, so it gives you more colors.
Aubergine is
Wait, why is skin brown?
See, sometimes when you say it's your favorite color, it's because you don't even know there's all these other colors, right? What if these were actually better colors?
Light
Do you
magenta,
even know what aubergine is?
Well, I guess it looks like that color.
Eggplant.
So for
Huh.
paint, you get more colors.
Wait,
Oh wait, is aubergine like a? Oh, it sounds like a word.
It's
Okay.
just like
what if
like a
there's a
different.
periwinkle?
I'm pretty sure it's like
Periwinkle. No, we need Nathan to decide.
I love periwinkle.
somewhere in like England or something.
No,
they call
I
it
did like-
aubergine. Eggplant.
Second last one and the last one.
Okay. All right.
Jade.
What color did you want?
Black.
Black.
Wait. You should
So
choose
second last one.
Can I choose
And
a
the last-
color? Light magenta. It's not on the.
All right. Winston.
The one next to Michael's. He didn't think of one.
What color?
He didn't think of one, so he just said one next to Michael. Pickle.
Pickle.
Pickle. Can I choose a color? I don't know.
Ernest, and then Michelle, and then Aiden,
Choose light one.
and then Lucas.
Wait, so we're choosing a dot? Light, so I hate guys.
Choosing 2.
Let's choose dark Ernest.
Choosing 2 dots and a color.
That's racist.
So Ernest, you're going with the yellows.
I honestly don't think there are any problems.
Okay. Well, let those be your colors and think. Michelle, what do you want?
What do you mean?
What color and what dots?
You know what means?
Flamenco. Mustard. Peacock. Where's black paint? What do you mean dot?
Baby
Pick a
blue
color and then
baby
pick 2
pink.
dots.
Where is black
You mean sangria? Whatever that is.
I got pink. Where's black pink?
Michelle, you're taking too long.
Wisteria.
What 2 dots?
Wisteria.
This and this.
Wisteria.
Alright, Aiden.
Wisteria.
Yeah. Hello.
Yep, color.
I did crimson.
Crimson. Alright, good choice.
Salmon.
And which
Then-
dots?
I choose the second last one on the bottom right,
You like to school 7.
Second last one. Yep, here.
and then
Oh, that's a nice color. Yeah.
Wow, crimson.
Wait,
the
choose
fourth last
salmon.
one on the top right.
Wait, can I choose another one?
Okay.
No.
Alright, and then Lucas.
Can I choose? Wait, there's only 2 dots left. Wait, 3 dots.
Oh, is Lucas still here? Lucas.
I know. One person can choose an extra color in the last one.
Wait, can I choose one?
Alright, we'll have to pass on Lucas for now. Okay, so out of these ones. Okay, I think.
Salmon like the pink.
See, the 2 black dots, okay? And the 2 wisteria dots. They kind of look a bit different just because they're on the same side of the square, right? Whereas the other ones go from opposite side to opposite. Yeah? That makes sense? So maybe we can look at the wisteria one, yeah?
No, I said like the bottom one.
Oh wait.
I said like the corner black was on the bottom corner.
Oh, so yours is not on the same side. So you're saying oh.
And mine's on the bottom left. Peter, pick the bottom right bottom.
Oh, well, this color's already taken. Oh, okay. Okay, so Ernest, this is black and yellow. Black yellow.
Black yellow.
The
one in the very corner.
Oh, there is nothing in the very corner. That's a black square. There's no bishop there.
Oh,
It's the wrong color.
Black square.
Okay, so then out of all of this, it's only the wisteria ones are actually on the same side, yeah. So maybe we can draw.
Skin 4. It's crimson. That's salmon.
So if you go like here,
Oh yeah, salmon.
see how would you?
Wait, is that salmon? Salmon. Yeah. Salmon color. I just make some sort of random weird. Turquoise? Is that turquoise? That's not called natural. Turquoise, that?
Yeah, see.
That I'm pretty sure that doesn't.
Hey, is it rainbow? That's not even straight.
It's not even straight.
We're not lying.
No, like it was the last place. Like diagonal.
All right, you guys are a bit too
Can I see the
clever.
color salmon? Can I see it?
Wait, diagonal? Nah, we're going curved.
What the?
Michelle wants to see the color salmon. Exactly.
What does salmon look like? I want to see the color.
It's basically just light pink.
I know, but I want to see the exact color.
I'm going to the exact color.
Wait, what is
Jason's
it?
going to the toilet. If anything be like diagonals. Nah, we've got curves. Diagonals, why not horizontal lines? We got diagonals? Nah, we got curves.
All right, yeah. Look at this. Let's suppose that wisteria traveled in this like dog shape.
Oh shit.
Can I see the color salmon?
Oh yeah, that does sort of look like a dog.
Yeah, it does if someone says it, then it makes it.
We've got dog lines.
I want to see the color.
It's on the screen. Sit down.
Dog lines?
Salmon.
You got straight lines or we got
Salmon.
dog lines?
Yeah, I want to see what it looks like.
Diagonals? Nah, we got curves. Where is salmon?
That's
He's drawing salmon. Salmon. Salmon.
Hey, get off.
Hey, get off.
I'm gonna
Salmon.
do it if you do it like that.
Alright.
Salmon. A salmon dog. Salmon.
Alright, okay, so this is kind of funny. We want to use your advanced minds to come up with good arguments. And at the moment, we're just laughing at the color salmon, and it looks like a dot. Okay.
It does.
We have to rise above this. Okay. And be smart. So can you explain why this path, for example, cannot work? This path cannot be done in captures.
Because you can't sacrifice the things twice.
Yeah, like if you had like a one sentence to summarize it before you had to go home, then yeah. But can we like spill out the details as it relates to this part?
Yeah, don't move pieces, guys.
Oh yeah, so these are don't move pieces. So can't move. So you can't move these.
We're just following the rules.
Why can't we move my pieces?
We're just following the rules.
Salmon.
Wait, but technically salmon's all of us, right? Technically salmon's all of us.
Why?
Because we were paid. Because we've all eaten.
Come on, guys. We're about to solve the hardest problem in the world. Okay.
Why
Sure. This is like sort of like an extension.
Extension? No, because having part of the solution was that any path. So we have to. So we didn't actually see it for every path, but we're meant to believe the idea works, right? So I want to test the idea on this wisteria salmon path. Okay.
You say fours can solve this problem. That's hard. The hardest.
I think some bright year fours can understand the solution to this problem. Okay. Okay. See, notice how the concentration is dying at this point.
Yeah, we're dying.
But
Concentration.
Huh?
64.
We have 10 minutes. So if you can last 10 minutes, I will be grateful.
Okay, sure.
Sure.
I'll be silent.
My brain's not working.
I'll be silent.
Okay. So can someone explain this? Is Lucas there? Aiden?
Yeah, I'm here.
Oh. You want to explain this path thing? Is Lucas there? Anyone want to explain this path thing?
I'm sure this boat wouldn't.
Okay, I'll explain it. Okay, so
Yay.
suppose it starts here, okay, and ends in here, okay.
Okay.
Okay. If it goes like this, there must be something that has to be sacrificed here, right?
The black dot.
Yeah, but there's only one thing on this diagonal apart from the thing that you started with, okay? But you can't sacrifice the thing that can't move, right? So you can only sacrifice the other thing, yeah?
Yeah.
Okay. Then you move along this diagonal, and you have to sacrifice something else to turn, okay? Yeah? And that will have to be this blue dot, right? Okay, because that's the only thing on that diagonal because you've already used the black dot, yeah? Okay. Now you continue on this path, and you have to sacrifice something here to turn, right?
Nothing. The green dot. My pickle thing.
Yeah, so this is the green one, yeah? And so there's only two things. So the whole point is there's only one thing in every diagonal. So whenever two diagonals intersect, there can only be two things, right? But since you used the first one, you have to use the second one, yeah? Yeah. So then when you get to here, you have to turn again, but you can't use the green dot, yeah?
Use the other black ones.
You have to use the yellow black.
Henry Stickman.
Okay, that's excellent. Oh.
I love Henry Stickman.
Okay. And then you go here to turn, right? But you can't sacrifice black yellow anymore because black yellow is already dead. Okay. And you can't sacrifice the thing that can't move. Okay.
You can't sacrifice
the other yellow one because that doesn't line up.
You're still using salmon, yeah.
Okay. So therefore, okay. Yeah. Yeah, and actually, like, if you make the main diagonal colors the same.
You're having a phone call. And you're having a scam call.
both of you guys.
And Ernest?
No, it's Winston and you.
Henry Stickman
Alright guys, so it's Winston and Nathan are going. But before you go, can you understand how the solution works, yeah?
Yes. Bye
So-
bye, salmon and pickle.
Yeah, so any 2 points. So the thing is, if these two are the same color, you'd have different cases. So to choose the other colored bishop on the main diagonal is actually pretty helpful. And once you do that, so the whole point is if you can't do it entirely with captures, you have to use an extra move. You have to use an extra move.
It's gonna break Michelle.
You have to use an extra move, which results in something else not being able to move. Okay, and then you're stuck again trying to navigate from there to there.
Let's want more Henrys.
Does that make sense?
We want more Henrys.
Yeah.
Just smash off her.
Yeah. So at some point,
This.
yeah. Hello? Hi, level 14. Yep.
Who's that?
Alright, it's the next group. So I'm meeting some new people.
This next group.
Alright, so Winston, Nathan, thanks for coming. You can keep the question sheets and stuff, yeah?
Can I take this? This is the money or something.
Yeah, you can keep all your stuff, yeah?
I'll this for money.
You gotta go downstairs. Press level 1 on the elevator, okay?
One of you could have a Henry
Come on.
Stickman.
Guys, Nathan, your bag's there as well.
Oh, okay, here, Henry. Oh wait, this is a potato.
It was the big
potato.
It was the big tall Henry. It was the big tall Henry.
It's a potato ball.
Don't forget this.
Yeah,
You gave it away. You
What's
didn't
the
have
homework?
them anyway.
What?
Yeah, what's the homework? Because I had one.
The homework is to understand this and to see if you can see why you can always do it in 197. But there's not really any homework, you see? It's just if you're interested, you can look at the problems.
By the way, you have the bomb. You have the potato bomb. You're gonna explode.
Alright, guys, you have to go, okay? Okay, so Aiden, can you stay around? I'm gonna need you, and
Okay.
I think Ernest, you're gonna go soon, but your mom's not here.
Not my mom. My mom won't be here. My dad.
Okay.
Because my mom's at work.
Yep.
Your
Okay.
dad left to get the milk.
2 to 11.
Your dad left to get the milk.
So I'm not even sure he has milk.
Alright, you guys have fun? That's good.
3.
You guys don't know each
It
other's
was in
school.
3, 2,
Just
1.
go shoot
He died.
Okay.
More Henrys are coming to your life.
Really exploded.
Okay, try to get that elevator. Come on.
More Henrys to your life.
Go to level 1, okay? Level 1.
No! Stop! Give it back!
Hardest problem in the world, huh?
Dang, I want you
Not
to
really
rip
hard,
that.
is it? Alright.
So once Henry Stickman, once Henry Stickman, the one that's dead, once Henry Stickman the second, who's about to be dead, because I was about to rip him. Third one, Henry Stickman the third, which I was about to rip, and so on.
Yeah, so the only thing we haven't addressed is how to actually do it in 197 moves, right? But that is actually not, I think, as hard as this. It's certainly more believable, okay? And if you do some kind of strategy with getting it on the diagonal, that covers most of the cases. Alright? Yeah, I might end the stream soon.
How do you even know the time? Just mix that.
It's 6:57.
Wow.
Oh, wait. It's 1 hour.
Oh, like on the oven.
Yeah, it's 1 hour late.
Oh, okay. So that's how you tell your time.
I mean early.
If it was 1 hour early, then it'd be like 5.
It's 7.
If it was 1 hour early, then it'd be 5.
Oh, wait, I mean 1 hour.
1 hour late, then it'd be
But it
If it
wouldn't
was
be.
1 hour late, then it'd be 6:58.
No, it's 1 hour
7.
early because it's 6.
Actually, you probably come up with a nice proof of why you can do it in 197. Because literally, to do it in 197, you just gotta just capture whenever you can. You know what I mean? It doesn't have to be a complicated strategy.
6:58.
Like, you can't really get trapped. There's lots of things blocking. You can just capture them all in one go.
16:58.
Yeah, there's probably a very nice indirect proof why it can be done in 197. Where is it?
So nobody solved this problem. Nobody solved this problem except for us. So that's good help. And multiple people. And time.
Alright, don't open the door. I need the toilet, yeah?
Okay. Yes! The Henry Stickman family. Henry Stickman family. Look, the Henry Stickman family.
Yeah, I'm gonna rip them to shreds.
No.
Oh, hi.
You can't rip a Henry Stickman.
Oh, okay. Yeah.
7 already. The end.
Yeah, 7 already. That was 1 hour late. Wait.
What? Oh, what time is Okay, wait. Yeah, so we basically just finished up with the previous. Oh, please have a seat. Yeah. But you already have a copy of the book, right?
Yeah.
Did you have a look?
A bit. I didn't understand anything though.
Oh, it's okay. You can have a look at it while you wait. I mean,
It's exactly 7.
Oh, that's my dad.
That's
hello? I'll send Ernest
And
down.
my dad.
Oh, that's
Winston and Nathan
Alright,
and my
see you,
dad.
Ernest.
Happy?
Bye.
Alright, Lucas. I don't know if you want to stay, you can. But I need Aiden to stay at least.
Yeah.